Good day everyone, this is a brief video. These amplifiers are discontinued now, but this is the Cerwin Vega CV2800. This type of amplifier was actually, the original OEM manufacturer was HPA, a high performance amplification in China, and they made the Samson SX 3200, the 2800, the B52 US series, as well as the American Audio V series, and they're basically all the same amplifier, simply put into a different case, and maybe a minor differences in the feature set. Here you can see this is the CV2800, and the 2800, it actually has an extra PCB back here that the Samson SX series does not have, and this PCB has extra inputs and outputs and extra settings that the Samson doesn't have. That'll be missing on the Samson series, but it'll still be there on the American Audio series. And the power supply, as you can see here, is all basically the same. Same as with the amplifier boards in each of the amplifiers, toroidal, the wiring. It's basically all the same amp, just in a different case. You'll notice in the back here, behind the amplifier, that's actually a PCB board from a Samson SX 1200. And as you can see, there's two extra heat sinks, and those are attached to diode bridges, which are basically the rectifiers. And I upgraded the rectifiers on that board, and I recapped the capacitors on that board, and I'm going to be juicing up the capacitors on that board. But I just brought it out to show that it's really the exact same board again, just designed differently for a more junior amplifier. And the junior amplifier, like the SX12, the rectifiers are on separate heat sinks on the power supply board, and in the Samson series and the Cerwin Vega series, the rectifiers are on the heat sink with the output transistors, and there's actually two of them. There's a 25 amp rectifier on one side and another 25 amp on the other side. So the 28 and 3200 series actually runs on 4 rectifiers total, 2 per channel. And other than that, one of the reasons I opened this up is a lot of people want to run their amplifiers on 240 volt if they're running a super system or whatever, and they feel that they may not have enough juice. Myself, I find I do have enough juice with 110 voltage, but I do run a lot of lines. But needless to say, one of the nice things about these amplifiers, and it's too bad that they are discontinued because they're better than a lot of the crap they make now, is that they are actually dual voltage. So you can run these off of 240 volt or 110. And you might say, well, geez, there's no switch on it. I have no idea how to do that. Well, that will be covered shortly if we come back here on the side of the power supply. Now, you'll see the writing here on the bottom. I'm trying to get in there so you can see it. Where is it there? Anyway, it's by the breaker here. There's a little 240 in brackets. You're probably not going to be able to see it, especially with this kind of camera. There it is. There's 240 in brackets in the back there. And then you can see there's the little green discs. Those green discs are the inrush current limiters. There's 4 of them. And then right on the other side of those inrush current limiters, if you come up a little bit more, there you'll see these are the transformer wires that are going into the power PCB. Notice one is marked white, WH, one is marked black with an X, one is marked red, one is marked black, and in brackets beside it, it has blue. And then there's a lone one. See that lone one there? Nothing on it at all. And that one is marked BK. And this is where the whole voltage change comes into effect on these amplifiers. Basically, in brackets, you see at the front it says 240 volt. On the other side, those inrush current limiters by the white wire, there's a 240 volt. You can see it there, and it's in brackets. And beside it, it says 120 volt. And what that basically means is there's two wires that you move to the bracketed terminals if you want 240 volt. And basically what that means is there's two wires you're going to move, the blue one and the black one. So the black wire that you can see already right there, where it says beside and has blue in brackets, you pull that wire off and move it over to the terminal, the empty one beside it that just says BK in brackets. Just pull that black wire and stick it on there. Okay. Now you move to your left and you grab the blue wire and you pull the blue wire where in brackets it says X. You pull that blue wire out and you move that one over to where it says BL in brackets. So you're basically putting that blue wire on the terminal where you just removed the black one. So this is how simple it is to change to 240 VAC. Move the black wire over to your left 1 and move the blue wire over to your left 2 to where you remove the black one from. And now you're at a 240 volt operation. Very simple, huh? Okay, that was basically all I wanted to cover. Other than that, I'm doing a few other things with these amplifiers that I could mention now, and one of the things that I'm doing is so you got to be prepared. I bought some of these things from China. If you look at these are DC terminals in the bag here. They're for plugging in external DC power supplies. And I will be taking my step drill bits that I got for $6 direct from China. I want $40 in the store for them, but from China you can get them for $6 delivered to your door. And I'm going to drill a hole in the back of the amplifier here and install the DC terminal, and possibly even two of them. I got lots of these. And this way I can install, I like to fool around installing internal lighting, and I would like to power my lighting externally rather than using the internal power. I would rather use the internal power just for my fans, but I would like the option to add external fan use as well with power. And all that is a matter of doing is installing some of these DC terminals in the back of the amplifier, and then using external power supplies to power whatever I want, whether it be fans inside here or lighting. So right now this thing's gonna, now that it's open, I've sort of just been cleaning it up. You can see right now what I do is I put some lighting in the front. You can't see it because it's hidden underneath here, and then there's another one hidden under here, and I've got a DC buck converter inside a static bag, sort of just tucked in behind here where it can't move anywhere, and I got that set to 12 volt just to light some lighting up in the front of the unit. and that's actually powered by one of the fan terminals in the back here. But like I said, I want to change that and go with external power. It'll make things nicer, and I'll have a little bit more control over lighting, and I could actually have individual switches and turn different lights on and off, etc. So that will be my next project. The other projects that I've been doing, these I'm probably going to leave, but like I say, there's the Samson there. It had 35 amp, it used to have anyway. Here you can see these are the bridge rectifiers. It had 35 amp, about 600 volt rectifiers, and I just put them up to the top notch 50 amp 1000 volt rectifiers. These are the same rectifiers that you'll find on amps capable of thousands of watts. But, just because I'm changing the capacitors on this unit, what I decided to do was change the rectifier, just for something to do, because they were only a couple bucks and a few solders. And if you come to the back here, something interesting, then you'll see there's the wiring for the back of the unit. And what I usually do is I put a little black dot where I'm going to be changing a capacitor out for a higher grade low ESR long life capacitor. So that's basically what I did, is I changed all these. You can see them here, and they're the same in all these units. All these types of capacitors are exactly the same in all the units. As you can see here, there they are. Those are the Zusclons still, and over here is the top of the line United Chemicon capacitors that I prefer to use. And there's a few extra items on here. This item here completes a circuit for bridging, and a lot of the other limiting functions are missing, but this is an extra circuit on this PCB where it's missing on this PCB, because those features are on the PCB on the back. So there is minor differences with this kind of stuff. So if you look at this, basically your transformer, this just screws onto the bottom of the amplifier. The transformer ground goes in here. Your left and right power just plugs into these, and then your power out to your amplifier comes from these plugs to the amp. And the amplifier returns over here, and then it goes out to eventually your speaker outputs. But yeah, this thing is going to be juiced up pretty well. Amazingly enough, if you look at the Samson SX 1800 power board, you can see the SX12 has a 3300 UF 100 volt cap, and the SX 1800 has a 4700 UF 100 volt cap. I find that to be quite low, so I'm putting 15,000 UF caps in replace of those, just for something to do. Juice her up a little bit. This is just sort of as a hobby thing and having fun. I got this amplifier for extremely cheap, and I'm just fooling around, maybe spending 40 bucks on it. 40 bucks worth of parts, not even. And to do these new caps and new caps here, and the new rectifiers, which is basically nothing. And then this will go back into the Samson SX 1200, which surprisingly enough, I bought it out of curiosity. It's actually a pretty strong little amplifier for the 1200 that it is. 300 watt RMS. The only thing I wasn't too happy with is the extreme low UF values that they put in this amp, so I'm going to make a change with that. And I didn't need to upgrade these, but I did it just because it was a couple bucks, and just so I could juice it up even more if I wanted to put a lot of UF value in here, and I never need to worry about that having a problem with the rectifiers taking it. Most of the time in these amps, the rectifiers are well over what's needed to begin with anyway. See, myself, like, I wouldn't bother going through the work and changing them, but I would prefer that these be 50 amp rectifiers, 2 on each channel instead of the 225 amps to make a single 50 amp that they have currently. But I'm not going to go through all the work of desoldering that and changing it just to change the rectifier. They're never going to go, and plus I'm not going to be changing these much. If anything, down the road I might put some 15,000 UF caps to replace these, but I'm not going to do that until one of the power supplies in the back officially goes. Once one goes, then I know that it's time to change the caps, and I'll change all the caps and all the larger caps in the power supply. This one here really didn't need any changing, but I'm doing it because I wanted to change these just as something to do. Like, this is just fooling around, and so I change all these at the same time. There's no sense, if you're going to take the board off, it's out, it's a lot of work. Once you got the board out, you may as well do the rest. You know what I mean? So you may as well get whatever work you need to get done, because the parts aren't necessarily that expensive at all for these kind of units. Here you can see where it's the back panel. What I do here, if you're ever having difficulty removing the solder from these terminals, and these are the big caps, where the bigger caps are. A lot of times the trick is if you have a heat gun and a solder wand, like my unit has both. If you use the heat gun and you heat it up and you put heat tape around, put heat tape and put the heat tape around all these where you're going to remove the solder from, just to protect the board. Here you can see I burned it once and I went, oops, I better go get my heat tape. And so after that I put my heat tape on myself after I made the error. But anyway, and then I used the hot air gun as well as the wand, and I heated it up to a melting point, and then when it was melted I removed the hot air wand and left the wand on here, and then used the solder sucker to remove the solder, and then I could remove the caps. But that's just sort of a little trick I found to remove the larger capacitors, because this solder doesn't melt that easily in the large quantity that's there, and that's a little trick to get the solder off without getting into using fancy $20 solder removal kits. And then once you get the capacitors out, I'm waiting still, but once the new capacitors come in, they'll go back in. I'll just put a couple blobs of solder there, and they'll be ready to go. It took me about 4 hours to get these capacitors off, because not only were they soldered in, but they were literally glued down to the PCB board, glued. So first I had to go around each capacitor and remove as much glue as I could. And then what I did is I tried to get under the capacitor with an X-Acto knife and cut the rest of the glue that was underneath it to separate the cap from the board. And then once I managed to do that, then I went underneath and desoldered the ends and pulled the cap off. And then after I had the caps off, I went around and I tried to clean up these as much as possible to get the extra glue off. But for whatever reason, for stability issues, they really glue these things down, and well, I'll probably glue them down again once, because they're not going to be needed to be changed for a long time, so I'll probably glue them down also when I put them back on and solder them, just like they do it. That's the new way. Instead of using 3 and 4 prong capacitors like they have in the past, what they do now is they just stick to the 2 prong and they glue them for extra stability. And as far as I'm concerned, it's probably a better idea because it's a little bit of a nightmare getting this 4-prong caps off. It's that much more work here anyway, so it's just as well that it's done that way. Anyway, that is my video of changing the power from 240 volt to 120 volt and vice versa on these Cerwin Vega HPA Samson SX American Audio V series amplifiers. Hope you enjoyed the video.